In April 2020, people started paying others to take their oil. Not a discount, not a promotion. Sellers paid buyers $37.63 per barrel just to remove the oil. This actually happened on April 20th, 2020. The WTI crude oil futures settlement price reached negative $37.63 per barrel. This was not a market failure. This was the physical world showing the financial system its limit. Capacity is full. Intro, negative $37.63. On April 20th, 2020, at 2 o'clock p.m. New York time, the WTI crude oil futures settlement price fell to negative $37.63 per barrel. Negative. Sellers paid buyers $37.63 per barrel to transfer the physical delivery obligation. Commodities can reach zero. Negative prices occur only when the cost of holding the asset exceeds its market value. Layer 1. The source that could not stop buying. Tech stocks gives you code that occupies no physical space. Buying one crude oil futures contract creates a legal obligation to accept 1,000 barrels of highly flammable industrial liquid on a fixed date. The futures market was originally designed for industry. Airlines used it to lock in fuel costs. But modern markets are dominated by hedge funds and retail speculators who own no refineries and no tankers. In normal times, they sell the contract before delivery day, and the game continues. In spring 2020, the pandemic halted global transit. Physical buyers disappeared. Contracts required physical delivery. Closing wells was not an option. Underground reservoirs operate under extreme pressure. Closing valves causes water and sand intrusion, destroying the well. Cost analysis showed that continuing to pump and selling at a loss was cheaper than permanent abandonment. So the machines kept running. Millions of barrels continued to flow into North American pipelines. A single Texas well outputs around 600 barrels daily, and pipelines require 800 to 1,000 psi to function. The system could not be turned off. Layer 2, the one-way squeeze. Pipelines are not storage tanks. They are high-pressure, one-way conveyors. Once oil is pumped in Texas, it cannot stop or reverse. It must be pushed forward by new supply entering behind it. The entire network terminates in Cushing, Oklahoma, the physical delivery point for WTI futures. Cushing has a total storage capacity of 90 million barrels. By mid-April 2020, tanks were at 97% capacity, leaving only 2.7 million barrels of space. Meanwhile, open contracts waiting for delivery totaled around 50 million barrels. 2.7 million barrels of space versus 50 million barrels of demand. The remaining space was only enough for about 5% of the need. Different oil grades cannot be mixed, and tanks have different specifications, so actual usable capacity was even lower. New oil kept flowing to Cushing daily. Pipeline pressure, pump speed limits, and oil grade coordination left no room for intervention. Any deviation in one link multiplied down the chain. Layer 3, the arbitrage machine. Storage in Cushing is controlled by a few midstream giants. When traders panicked over delivery obligations, these companies saw a rare arbitrage opportunity. The market was inverted. Spot prices crashed, but future contracts remained high. Owners of empty tanks could take cheap spot oil, store it, and sell future contracts at higher prices without producing any new oil. The final 3% of capacity was locked up internally. Building new tanks takes 18 months. Dumping oil meant massive EPA fines that could bankrupt companies. Traders had only two choices: pay huge fees to take delivery or pay to get rid of it. The settlement price settled at negative $37.63. At that moment, the power to set the price no longer belonged to the oil. It belonged to available storage space. Layer 4, the overflow to the ocean. With land storage maxed out, the pressure spilled into the ocean. More than 800 very large crude carriers, each longer than 3 football fields, were converted into floating storage. Each ship could hold about 2 million barrels, for a total of roughly 1.6 billion barrels, equivalent to several weeks of global demand. Daily rental rates surged from $20,000 to over $300,000, a 15-fold increase increase. Owning an empty vessel became a high-yield asset without moving any oil. Global shipping efficiency plummeted as the world's fleet became a static storage system. Layer 5. The cost of extreme efficiency. Wall Street's algorithms can calculate capital flows in milliseconds, yet they could not calculate the remaining tanks in Cushing. This crisis exposed a systemic design flaw. In pursuit of extreme efficiency, buffer capacity was systematically eliminated. A zero inventory, high density system is efficient 99.9% of the time. When an extreme event hits the physical limit, collapse is the result. Power grids. When load exceeds transmission capacity on 500 to 765 kilovolt lines, there is no buffer. The system triggers blackouts to prevent physical damage, as seen in Texas in 2021. Ports. When unloading speed outpaces trucking capacity, yards fill up and lock the entire supply chain. Los Angeles port peaked at over 15,000 TEUs daily. Computing. When heat density exceeds cooling limits at 30 to 40 kilowatts per rack, servers must throttle performance by 50% or more to prevent hardware failure. The 21 minutes of negative pricing served as a verdict on the physical limits of complex systems. Layer 6. The universal variable. Every complex system is ultimately constrained by its smallest physical bottleneck. Crude oil. Cushing tanks reach capacity. Shipping. Floating storage occupied space and burned 1.5 tons of fuel per ship per day. Electricity. Grid lines reached full rated voltage of 500 to 765 kilovolts. Computing. Heat limits reduced processing capacity by 50%. Ports. Container saturation exceeded 15,000 TEUs daily unloading. The result? Chain reactions. One full link stalls the entire network. Scarcity of capacity inflates costs. Limits in one system spill over to others. Layer 7. The coming capacity crises. Oil, power grids, ports, computing clusters. These networks that sacrificed buffers for efficiency carry systemic risk. When capacity is fully occupied, remaining space becomes the scarcest resource. Every participant is forced onto a single path. Modern systems face parallel threats. Renewable energy grids, insufficient storage prevents balancing supply fluctuations. Port logistics, unregulated container yards cause paralysis. High-performance AI clusters, inadequate cooling halts computation. The April 2020 oil price event was a live system test. Financial numbers can expand infinitely, but the physical world does not negotiate. Oil, power, ports, compute. The next capacity crisis is already building. What's your take? Is it renewable energy grids, high-performance AI clusters, or local port storage? Leave it in the comments below.